In this question, we are required to find the first four derivatives of f of x and then find the 19th derivative. So I'll start with part one, which is finding the first four derivatives of f of x. Is cos x. The first derivative of this function will be negative sine x. The second derivative of this function will be negative cos x. And the third derivative of this function will be negative sine x, negative sine x, which is just sine x. So negative sine x, which is just sine x. Now, so part two, we need to find the 19th derivative. Now, what you may want to do here is to try and look at the pattern to try and come up with a way of finding the 19th derivative. So what I suggest is that maybe you can just draw a table here. If you look at this pattern, the fourth derivative will be cos x, which is the same as the original function. Okay, and then the fifth derivative will be negative sine x. So the pattern repeats itself. So what I'm going to do is basically to organize this information so that on the left I have the derivatives, and here I have the nth derivative. Okay, so on the left I have derivatives, and on the right I'm going to write down the numbers representing those derivatives. So for example, this will be the first derivative, and then second derivative, third derivative, fourth derivative, fifth derivative, sixth derivative, seventh derivative, eighth, ninth, 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, and 19. Okay, and you can see that the 19th derivative here will be sine x. Okay, so we can go ahead and write that and answer the question, which is now part two, that the 19th derivative is sine x. Okay. In this question, we are required to find the first three derivatives of g of x, and then we are supposed to find the 19th derivative. And using the coefficient of the 19th derivative, we need to find what p is. So the first part, which is just finding the three derivatives of this function, we can use power rule. So the first derivative will be k multiplied by x to power k minus 1. This is just power rule. The second derivative will be k multiplied by k minus 1, x to power k minus 2. The third derivative will be k into k minus 1, k minus 2, x to power k minus 3. So once you have those, we can use this pattern to try and establish a formula. So we need to find a formula on how to go about this, which means we can go ahead and um, organize all this information in a table. Okay, so what I'm going to do is in that table, I'll look at the coefficients, and I'm also going to look at powers of x. Okay, this case here, and of course the derivatives. Okay, so in a table here, I have the first column would represent the nth derivative, so first, second, third derivative. Then we have the coefficients of x and powers of x. Now, from what we have in the previous working out, we have the coefficients are k multiplied by k minus 1, k into k minus 1 multiplied by k minus 2. So let's plug this information here. So we have k, we have k into k minus 1, we have k into k minus 1, k minus 2. Now, one thing that you need to remember here is that using the factorial notation, because you always have to look at the question that you're given to figure out what you're trying to find. Now, if you look at that bit, here we have k factorial over k minus p factorial. Now, for example, if you have something like k here, that could be something like k factorial over k minus 1 factorial. Because if we simplify this, we shall end up with k multiplied by k minus 1 factorial over k minus 1 factorial, which means this cancel to give you k, which we have on the left here. So what you are saying here is that instead of writing k, we can write k factorial over k minus 1 factorial. So on my table here, I'll say that this is equal to k factorial. So k factorial over k minus 1 factorial. Okay. Now, in this case here, again, we can show it here that this can be written as k factorial over, I'm going to write factorial, so k factorial over k minus 2 factorial, because this will be k into k minus 1 multiplied by k minus 2 factorial over k minus 2 factorial. And these two cancel, leaving you with k into k minus 1, which is basically what we have here. So, which means in our table, we can, instead of writing k into k minus 1, we can write this as k factorial over k minus 2 factorial. Okay? And here we can write this as k factorial, just using that pattern, k minus 3 factorial. All right, back to our pattern again. Let's look at the powers of x. The first derivative, the power of x is k minus 1. Second derivative, the power of x is k minus 2. Third derivative, k minus 3. So we can include that information here as well. So this is k minus 1 here, k minus 2, and k minus 3. Okay, so back to the question. They're asking us to find the 19th derivative. So 19th derivative in our table, suppose you want to find the 19th derivative here, that will be equal to, and you can see the pattern here, 1, 1, 2, 2, 3, 3. Okay, another pattern, k minus 1, k minus 2, k minus 3. So, which is basically something that can help us to find the 19th derivative. That's what we need. Anyway, the 19th derivative here will be given by k factorial over k minus 19 based on the pattern that we have, factorial. And the power of x will be k minus 19. Okay? So back to our question. The 19th derivative will be equal to k factorial over k minus 19 factorial multiplied by x to power k minus 19. Okay? And which means that because the question is asking us to find the value of p, which means that p will be equal to 19. Okay? Because that's p here, and we can see that p is equal to 19.